All right, today we're going to be looking at tables, graphs, and equations. So you can use tables and graphs to represent equations that involve two variables. The independent variable, keep in mind, independent variable is typically the cause of a story or the thing that happens first. And not only that, it's used with the variable x, and it's graphed on the horizontal axis. Keep in mind the horizontal axis. I'll highlight the horizontal axis down here. And notice what is next to the horizontal axis is the letter x, or the variable x. And then moving on to the dependent variable, I'll highlight the dependent variable in a lighter blue. And the dependent variable is graphed on the vertical axis being up and down. And if you notice the vertical axis that I'm highlighting now, I also happen to highlight the variable y because dependent variable is typically the effect of a story or the thing that happens second, and it's usually represented by the variable y. So now it says the table and graph below represent the equation y equals x plus 2. And the reason why it represents y equals x plus 2 is if you take your independent variable, like the number 1. So I'll use green to kind of show you what I'm talking about. If we take the number 1 and we plug it in for the x right there. So what is 1 plus 2? Well, 1 plus 2 is 3, which is why the variable, or the dependent variable, or the y, is a 3. So then the ordered pair is 1, 3. Now if you happen to take a 2, plug a 2 in where x is, well, that tells us that y equals 2 plus 2. What's 2 plus 2? It's 4, which is why I circled 4. So the ordered pair for the x comma y ordered pair is 2, 4. And then the last one, you see here, it wants you to plug in a 3. Well, what is 3 plus 2? That's 5, which is why you see a 5 right next to the 3. Now we have to plot these ordered pairs, right? We should hopefully know how to plot 1, 3. That means 1 over and 3 up. So 1 over and then 1, 2, 3 up. That right there, that green dot, is the ordered pair of 1, 3 plotted on our grid, right? So then, of course, there's 2, 4. So that's 2 over and 4 up. There's that one. And then last but not least, 3, 5, right, is 3 over and 5 up. And there it is. And then, of course, you connect all the solutions on the line. And here's a little note I gave you, and it reads, when you draw a line through the points, you graph all the solutions of the equation. So all those points on our graph or our coordinate plane represent solutions. All right, this will make more sense when we get into one. So it just says right here, graph y equals 3x. Well, the easiest way I know how to do this is to make a quick table. The easiest way I know how to do this is to make a quick table. So I'm going to set up an x and a y table. And I'm just going to choose 3 easy numbers. The earlier example had 1, 2, and 3. I'm actually going to choose 0, 1, and 2. So watch what happens. I have the equation y equals 3x. I'm going to take 0 and plug it in where the x is in our equation. So this reads y equals 3 times x. Well, I'm saying x has to be 0. Why? Because I made it up. That's why I'm trying to choose easy numbers here. What is 3 times 0? 3 times 0 is 0. So this means if x is 0, what does y have to be? It's 0. You're looking at it right there. So that means 0 and 0. So one of our ordered pairs that we're going to have to plot is 0, 0, which looks like someone's face and a nose. Moving on. Now I'm going to use the number 1. So I'll highlight the 1, and I'm going to plug in the value of 1 for our x. Well, what's 3 times 1? 3. So what does y have to be? 3. So that ordered pair is going to be 1, 3. On into the last one. I have to take the x value of 2 and plug that in for my x. So y has to be equal to 3 times 2. Well, what's 3 times 2? That's 6. So that means y has to equal 6. So a 6 goes right there on our table. And our last ordered pair is going to be a 2, 6. So now the last thing to do is plot the ordered pairs. Well, 0, 0, there's 0, 0. That is my 0, 0 ordered pair. And then 1, 3, that's 1 over and 3 up. 1 over, 1, 2. There is 1, 3. And the last one is 2, 6, 2, 6. 2 over and 6 up. There's my 2, 6 ordered pair. And what we typically do is connect the dots. And that right there is called it's actually called a linear equation. And the reason why it's called a linear equation is I'll give you a big giant clue. It creates what type of line? It creates a straight line. So that's why it's called a linear equation, because you got the word line in the word. And so it basically creates a straight line. There you go. That was graphing y equals 3x. That's what it looks like on the graph. We're going to do another one, a harder one this time. So this equation reads y is supposed to be equal to 1/2 of x, which of course means multiplication, 1/2 multiplied by x plus 2. We have to graph these. How do we graph them? Well, it's simple. Pick some easy numbers. Okay, so I'm going to make my x and y table, and let's just go with 1, 2, and 3. Okay, and if these don't work, we can pick different ones, but it's going to be pretty simple. We take our first one, which is a 1, and we plug that in to the equation. I'm going to use green this time. This means we have to write y equals 1/2 times 1, because I'm saying x is 1, and I have to add 2. Well, what is 1/2 times 1? Well, that's a half. Well, what's a half plus 2? Well, hopefully you know that a half plus 2 is 2.5. So this means that our y value is going to be 2.5. Now let's try 2. Now I'm going to plug in 1/2 times 2 plus 2. Well, half of 2 is 1, and 1 plus 2 gives me 3. So this means y has to equal 3. So our y value will be 3 when x is 2. We keep going here. Now let's do 3. So if I put a 3 in this time for the x, it'll say 1/2 times 3 plus 2. Well, what is half of 3? That's actually 1.5. Okay, 1.5 times 3 is, 1/2 times 3 is 1.5 plus 2. Well, that's 3.5. So that means that our y value when x is 3 has to be 3.5. So you should start to kind of recognize a pattern when you look at this table, right? Our x values went 1, 2, 3. Our y values went 2.5, 3, 3.5. So I'm going to write down these ordered pairs, and then we're going to graph them. Okay, so our first ordered pair, I'll use black this time, is 1, 2.5. Our next ordered pair we have to graph is 2, 3. And our last one is going to be 3, 3.5. We're just going to plot these. So here we go. 1 over 2.5 up. There's right there is 1, 2.5. Now let's do 2, 3. 2 over 1, 2, and then 3 up. 1, 2, 3. There is 2, 3. That one right there represents 2, 3. And the last one is 3, 3.5. So 3 over to the right and 3.5 up. There's 3.5. So that last dot, or plotted point, represents the ordered pair for 3, 3.5. And then what do we do with the dots? We connect them. And then this line that it creates is a straight line, which is why this is called a linear equation. All right, on into one more problem that we're going to take a look at. This time, we have to write our own equation. All right, so it costs $25 to rent a kayak. Says it right there. Plus $8 for each hour. So there's some codes here. $25 to rent a kayak, plus, what does plus mean? Plus means addition. Plus $8 for each hour. Well, each is code for multiplication. Normally, in a word problem, if you read the word each means to multiply. Okay, so now they want us to write and graph an equation that represents the total cost C in dollars. So we have to start with C equals the total cost for all of this, for renting a kayak for an unknown amount of hours, which is why they chose H for hours. So let's see here, $25 to start, right? Plus $8 for each hour. Well, that's 8 times H, and I could put 8.H, or I could simply squish them together and write 8H. So this right here is our equation that involves two variables, but now they want us to graph it down below, right? So you can see the graph down below. So I'm going to use, instead of X and Y, I'm going to use H and C. H represents the number of hours we are going to rent the kayak, and then C happens to be the total cost. This is where you make up numbers. Let's just start with easy ones. 1, 2, and 3. Those are pretty simple. So I'm going to use my equation that we came up with and start plugging in the values. So let's go with green and start plugging it in. So the cost is going to be $25 plus 8 times 1. Why am I choosing 1 to start with? Because that's what I just wanted to use for 1 hour. If I'm just going to rent the kayak for 1 hour. So here comes the math. 8 times 1, 8. And we always do that first because it's multiplication. Well, multiplication is before addition. Then we add, what is 8 plus 25? That's $33. So that would mean for 1 hour, it cost me $33 to rent the kayak. Now we're going to plug in the number 2 this time. Let's say we rented it for 2 hours. So start back over, and it's going to be 25 plus 8 times 2. 8 times 2 is 16. And then I have to add my 25 plus 16, and 25 plus 16 is 41. So there's my 41. And the last one we're going to plot is if we did 3 hours. We are going to rent our kayak for 3 hours this time. All right, so I'm going to highlight my 3 to show you I'm using the number 3 for our variable H. So it's going to be 25 plus 8 times 3. Well, 8 times 3 is 24. And of course, we have to add the fee of $25, and 25 plus 24 is 49. So the cost is going to be $49. And you should notice a pattern. What is it jumping by every time? What is it jumping by each time? It's jumping by 8. Why is it jumping by 8? Well, because it's $8 for each hour that you choose to rent the kayak. So now I got to plot these points. The ordered pairs. Our ordered pairs are going to be 1, 33. It's going to be 2 and 41. And then it's going to be 3 and 49. All right, so let's just plot them. All right, 1 hour. So here we go, 1 hour, or 1 on the x-axis. Keep in mind this is the x-axis, is $33. So 1 and then up to 33. 30, 1, 2, 3. Then we got to do 2 hours. 2 hours would be $41. 2 and 41. And then 3, and you'll notice something on 3. 3 goes off our graph. We don't have enough space on our coordinate plane to plot it, but it would be 3 hours and 49 would probably be, take a guess here, if we connect these two dots, we'll kind of get an idea of where it should be, right? So that would be plotting the equation. All right, so that was everything. That was taking a look at tables, graphs, and equations.